Hi, this is lesson 7.6, the assignment answer key for page 287, number 1 to 4 in Math 7. It's all about tree diagrams, and it says we need to list the sample space for each pair of independent events and ask why are the events independent. So we need to answer that why are they independent for each question and come up with the sample space. Now looking here, question 1 says this. It says this: roll a die labeled 3 to 8 and flip a coin. So we have two events happening. There's the die, which is a single dice, and then there's going to be a flipping a coin. Okay? So the options, it says, are from 3 to 8. So this is a strange one. They replace the 1 and the 2 with a 7 and an 8. So the options would be a 3, a 4, a 5, a 6, a 7, or an 8. And then after the die is rolled, then a coin is flipped. So let's say at first the dice roll and it's a 3, and then the coin's flipped. What are the two options for the coin flip? It could be heads or it could be tails. What about if the die was rolled and it was a 4? What are the options for the coin? Did the coin get affected by this? No, it didn't. It's still heads or tails. Still heads or tails. What about if the die was rolled as a 5? What are the options for the coin? It's still heads or tails. It's still going to be heads or tails for all of these options. It's still that way. And did the coin flip affect the die at all? No, it getting a heads or tails didn't affect these numbers that were rolled. The roll happened and whatever it landed on is what it was. So these are independent. Why? Because the outcome of the coin doesn't affect the outcome of the die and vice versa. So I'm going to write that at the bottom here. The outcomes of coin and die don't affect each other. Sorry, affect each other. So they are independent. You know, if they threw in a rule that said, if you flip a heads and an odd, it doesn't count and you have to redo it, then it wouldn't be independent. It'd be dependent. But because there's nothing saying that, what happens on either of those doesn't get affected by the other. And the sample space is the same thing as our outcomes. How we do this is we start on the left and follow the line. We go 3H. Then we follow the next line, 3T. 4H, 4T, 4H, 4T. It's basically listing all the options that are presented here is outcomes, and the sample space is a list of all of them. Okay, so there is our list. That's our sample space. So it's basically each of these numbers written twice, and then HT written beside all of them. So there are 12 numbers combinations in the sample space, so it's going to be out of 12. And the answering that question of why are they independent is 1. So question 1A is out of 13. Let's do 1B. Question 1B says that there's a tetrahedron, which is just a 4-sided die. It's a triangular pyramid. And a spinner or spin, and there's 3 different colored sections. My book is actually not in color, but I know that it's B, Y, and P, so I'm guessing it's blue, yellow, purple. Maybe it's black, yellow, pink. I might be wrong, but I'm going to go with blue, yellow, purple. I'm just going to use these letters though, so your answer should still show up the same, even if I'm saying the other words. So let's start with the tetrahedron. So the tetrahedron is our first event, and our second event is going to be our spinner. Okay, so let's write down the options. We have a 1, we have a 2, we have a 3, and we have a 4. And our spinner, our options are blue, yellow, and purple. So if you rolled a 1 and then spun, you could then get a 1 and a blue, or you could get a 1 and a yellow, a 1 and a purple. If you rolled a 2, you could still get a blue, a yellow, or a purple. That die does not affect, the tetrahedron die does not affect what the spinner does because they're independent events. Again, it's going to be blue, yellow, purple, blue, yellow, purple. If you rolled a 3 with that die, you roll it, and you get a 3, and then you spin the spinner. Can one of these options be outruled? No, it can't. It's still there. We've got all the different options that are possible. We've got all the different options that are possible. So here is our outcomes, which happens to be our sample space. We've got 1B, 1Y, 1P, 2B, 2Y, 2P, 3B, 3Y, 3P, 4B, 4Y, ooh, that's a weird Y, and 4P. So those options, I'm just following the lines through, seeing what pairs of this could be possible and what could happen. So there's our sample space, and why are they independent? Because the tetrahedron and the spinner don't affect each other's results. They are independent because the tetrahedron and spinner don't affect each other's results. There are 12 different options in the sample space, so that's 12 marks plus 1 here. So question 1B is out of 13. All right, and 1C says we're rolling a pair of dice labeled 1 to 6. So each of them have the numbers 1, 2, 3, 4, 5, 6. So let's write down these options. Now you guys are probably noticing that I'm like leaving some space here, and you might be wondering how I'm doing that. I know that the second option has 6 different values, right? I know that there's 1, 2, 3, 4, 5, 6. 6 options that it could be. So I leave that many spaces for 1 to have. And then I leave a couple so that I have my 2 in the center. Notice here it's 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And then the next one is the one I'll do 1, 2, 3, 4, 5, 6. I go 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6. That's kind of how I space this out. It doesn't always work. My bottom one I'm going to have to squish together a bit. Or I might squish it as we go and not follow the lines. I'm going to try to keep it as organized as I can still. But that's just kind of what I do when I have sample spaces and different probability options. I zoomed out here so you can see the whole page. So what I did is I wrote down the 6 options that the first die could have. And then for each of those, I wrote down the amount, 6 different options that the second die could roll. So if the first one is a 1, the second one could still be a 1, 2, 3, 4, 5, or a 6. So our sample space would be a 1, comma, 1, 1, then a 1, 1, then a 2, 1, then a 3, 1, then a 4, 1, then a 5, 1, then a 6. So I'm just going to write 1 6 times, and then commas. Why am I putting commas in here? It's so that you don't accidentally think that it's 11 or 12 or 13. Okay, there are options. And then the next ones are 2 and then a 1, 2 then a 2, 2 then a 3, 2 then a 4, 2 then a 5, and 2 then a 6. So 2 comma, I'm just going to write this down because it's a little quicker going this way. Okay, I'm going to have to squish this down a bit so that it all fits on the page. I have 3 then a 1, 3 then a 2, 3 then a 3, 3 then a 4, 3 then a 5, 3 then a 6. Then I have a 4, 1, 4, 2, and so forth. All the way down till 6, 6. Now, just a quick hint, the number of options from your first event and the number of options for your second event, if you multiply those numbers, that will be the number of things that are here if it's an independent event. So 6 options, 6 options, 6 times 6 is 36. So I have 36 different combinations down here. Now the difference between a sample space and outcomes, as far as I understand, is that outcomes would be often you adding these together. So this would be 2, this would be 3, this would be 4, that sort of thing. So yeah, there's 36 different combinations here. So this is out of 36. And then there will be 1 mark for saying that it is independent. Why? Because one die does not affect the other, which would be 1 mark. So question 1C is out of 37 marks. It's quite a bit. I'm going to stay zoomed out for question 2 because question 2 says that we need to use our results from 1A. So if you didn't get 1A correct, question 2 is probably going to be wrong. So you need to maybe fix your 1A before you continue watching this video. Take a note of what time you're at. We're at 11 minutes and a half. So looking here, it says that ASEA wins if an odd number or a heads show. So if it's odd or it's heads, ASEA would win. And Roberto wins if the number is less than 5. Who is more likely to win? So we need to come up with the probability for each of these and then compare which one has a higher % chance of winning. So looking at this sample space, odd numbers would be what? 1, oh no, why? Because it starts with 3, 4, 5, 6, 7, 8. Remember, those were the numbers that there are. So it's the ones that have either a 3, a 5, or a 7. And heads, it's the ones that have the H. So looking at these, let's make a list of the ones that ASEA is. Well, there's 3H has a 3, 3T has a 3, 4H has an H, then we've got 5H, 5T, we've got 6H that has a heads, we've got 7H and 7T, and then we have 8H. So counting that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. 9 options out of what? There's 12 options total. So 9 out of 12, which is, we can divide both these by 3. We end up with a 3/4. It's a 3/4 chance, which happens to be 75% chance that ASEA would win. Now looking at Roberto, the options that are less than 5. So which numbers are less than 5 that could be rolled on this die? Well, it's a 3 or it's a 4. Could be a 3 or a 4. So looking at the options that have 3 or 4, there's 3H and 3T, and there's 4H and 4T. We don't include 5 unless it says less than or equal to. It didn't say the or equal to part, so we don't include 5. So that means that there's 4 options out of 12. We can divide both by 4, and we're left with 1/3. And we know that that is 33.3 repeating %. So who is more likely to win? It's the person who has a 75 here. ASEA is more likely to win. Why? Because 75 is greater than 33. Forgot my repeated sign. Okay, you're going to get 3 marks. Why? Because you needed to have figured out this 75, this 33, and then made the comparison to get your answer. So I'm making this out of 3 marks for that reason. 75 is 1 mark, 33.3% repeated is another mark, and then the comparison that says ASEA is your other answer. So I'm looking for those three things. If you wrote this sentence here, that could be your answer because it has those numbers in it. So question 3 says that we need to use question 1b and name an outcome that happens or occurs about 1/2 of the time. So looking at these outcomes, what's something that happens about 1/2 of the time? Now there's actually a few different answers that I came up with. One of them would be, look at this. Our numbers, we've got 2 odd numbers and we've got 2 even numbers, right? Half of these options have an odd number. Right? We have 1, 2, 3, 4, 5, 6 options of the 12 are odd numbers. So you could say odd numbers. Or you could say even numbers. Why? Because there's 3 2s and there's 3 4s. 3 plus 3 is 6. Out of the 12 would be half. So you could say all the even numbers. So the options that have even numbers. Or you could say less than 3. The tetrahedron has a less than 3. Or you could say greater than 2, right? All the options that are greater than 2 would be these ones. It would not be easy for you to use these options that are the spinner ones. Why? Because it's split up into 3 groups, which would be thirds, right? Not halves. It would be harder to do. But you could say number that, say either an odd number, so these ones, an odd number and yellow, so these ones, right? Or an even number but not blue, which would be these ones. It'd be a weird way to word it, so there's some more complicated ones than these here, but these are the more simple ones. But there are other options for this question 3. But any one of these 4 and possibly some others would work. And all you need to do was to write down what it was for this. It didn't say you had to explain, so it's only going to be out of 1 mark. It says that we need to use question 1c. And how often are both numbers rolled greater than 4? So both of them have to be greater than 4. If one is but one isn't, that doesn't work. It has to be both are greater than 4. So let's look at that question. All right, just to recall, it was the one where there were 6 options on one die, 1 through 6. And then the second die was rolled and they also had their own options, which meant that we got this sample space here. Now looking at this, which ones have both their options greater than 4? Not this one, not this one. This is not even greater than 4. It's equal to 4. Greater than 4, 5 is greater than 4, but this 1 is not. So it's still not. None of these are, none of these are, none of these are, none of these are, until you get way down to the bottom here. 5 is greater than 4, but 1 isn't. 5 is greater than 4, but 2 isn't. 5 is greater than 4. 4 is equal to 4, but it's not greater than. However, here we've got 5, 5. We've got 5, 6. Keep going. 6 is greater than 4, but 1 isn't. So forth, so forth. 6 and 5 is, and 6 and 6 is. So how many options are there? There's 1, 2, 3, 4. So to answer this question, there are 4 options. There's the 5, 5, there's the 5, 6, there's the 6, 5, and the 6, 6. Those are the options. There's 4 options out of 36 that are greater than, both the numbers are greater than 4. So 4 over 36, we could divide this by 4, divide by 4, and get a 1 out of 9 chance. We know that 1/9 is the same thing as 11.1 repeated percent. So how often are both numbers rolled greater than 4? It's 11% of the time, or 1/9, or a 1-to-9 ratio. Any one of those works. You only needed to come up with one of those for 1 mark there. So looking at assignment 7.6, page 287, number 1 to 4, It's going to be out of 68 marks. 13 for question 1, 13 for question 1B, 37 for 1C, 3 for 2, 1 for 3, and 1 for 4.